All right, hey everybody, I'm Mark. I'm a product manager at Red Hat, although for the purposes here, I'm a member of the Podman community. Along with me, I have
Stevan Le Meur. I'm also product manager working on a Podman desktop at Red Hat, but also on various developer tools. So, as you know, Podman is an open source tool for working with containers. Just as we see in this beautiful illustration with Seals. In addition to that, it's also a tool that allows you to work with pods, just like the pods that you have in Kubernetes. But it also appears that a group of Seals is called a pod, so hence the name for Podman, for Pod Manager, and all the cute graphics that you can see all around the project. Those little seals, they are very happy to be here today. They love Kubernetes, of course, and very happy to be here at Reject. So thank you for having us.
And by the way, I want to say we actually got originally rejected from Rejects, which is pretty incredible. So I think we're very special. There's look, a lot of people would think of Podman, and I correctly, right, as basically a Docker clone, and it is that, right? It is that. It is an API and CLI compatible container engine, but it has a different design philosophy, which is summed up in the mission statement here, and as well. Oh, actually, we can just go straight on to the next one. So, looking back from history, it's been about 8 years since Podman started. Cryo actually came first, and Podman was forked from Cryo into a project called Kpod. Eventually, proper Podman came out and gained a REST API, as well as Compose support, which we'll dig into a little bit. And what's interesting here, since we're at KubeCon, is the added support that came in Podman 4 for the Kubernetes API. So without any cluster around whatsoever, kind or nothing, Podman itself supports the kube pod spec, containers, daemon sets, deployments, persistent volume claims, config maps, and jobs. And while some may feel that container engines are kind of a done thing, we beg to differ. And the last couple of years of Podman development, I think, has shown that. One of my favorite features of the last couple of years is Quadless, which is this tight systemd integration. I assume everybody here loves systemd. And other key features we're going to look at a little bit are artifact support, Z-standard chunks, and ComposeFS. Oops. Just some, the usual vanity stats. We've had a lot of contributors over the years. We have had maintainers outside of Red Hat, and we're looking forward to more as part of the CNCF. I update this slide whenever I deliver it because it seems like the star count keeps climbing. I think we got a nice boost from joining the CNCF sandbox.
Thank you, Mark. So for Podman Desktop, Podman Desktop provides an intuitive and user-friendly interface on top of Podman with a lot of developer flows to help working with containers as well as working with Kubernetes. So it simplifies the container management. It will streamline a couple of workflows, but one which is important, and I will show that in the demo, but it's really the transition from local to production. So the tool itself runs on Mac, Windows, and Linux, and one of the primary goals is to get you up to speed and install and configure and set up to work with containers. So it will manage your container engine, it will keep it up to date, and so on and so forth. It will provide UI for containers, pods, and it will have compatibility with other engines as well. It's enterprise ready, so you can use it behind your VPN with your own proxy configuration. You can connect to any registries you want. And it will also allow you to connect to and bridge to remote Kubernetes environment. But really, our mission is really to focus on the application developers to help them going from the application to containers and then to pods and then to Kubernetes and making this smoother and easy to adopt. The project starts in 3 years ago, actually. And again, while I mentioned that we've been building it on top of the Podman capabilities, it's also been designed by abstracting away the container engine and to support multiple providers. That's very important because this is how the openness reflects in the project commitments for the developer choice, for enabling the users to work with the preferred tool that they have. In terms of status, since 3 years, we've been reaching more than 2 million downloads in total. And we have more than 110K monthly active users. Number of stars is slightly less than Podman, but it's growing as well. And users who are using it are usually quite happy because they keep using the tool. We try to ship releases every month and a half. And in the last 12 months, we've been focusing on enabling the extension, working on the Kubernetes UI that I will show during the demo, and having built-in guides and onboarding guidance as well. So let's get into it, in fact.
Yeah, I've got a couple of highlights before we get to actual demos. I mentioned Quadlet. I just wanted to throw a typical one up here. Not a complex one, right? This just starts Postgres. You can change the environmental variables. You can override any of the command line arguments you need. You can harness the full power of the command line if you need to, but what it gives you is, I just want to turn this container into a service. And if you want to do that easily, you can see it. And by the way, the little command that's the subheading there, that will show you what it actually generates out to. It'll show you the boilerplate that you're not doing when you create one of these files. Again, then it becomes like a normal systemd unit. You can use any of the dependency management that's built in there. I think there was something else I wanted to mention about it. We'll pass. All right. OCI artifact support. This is experimental. It's new in Podman 5.4. And basically, it should feel very at home to users of container engines, right? It uses a backing store locally like you would with your container images. So everything is the same. Podman artifact ls, Podman artifact push pull rm. You can add a new artifact. You can, it's not in here, but you can -- append an existing file to an existing artifact. You can extract out one file from a multi-file manifest and so forth. So it's, it's kind of a utility. I think some of these features should end up in the future in Scopio as well, but right now the development is being done in Podman. All right, as a product manager, I'm going to take a little risk here, and we'll show you a few things. All right, thank you much. All right. Don't want to miss anything here. Okay, so I mentioned compose support. Let me clarify a couple things. So there is a project called Podman-Compose that is in our namespace. I don't tend to use that or suggest it. It's not as mature. If you really want to use Docker Compose, I honestly suggest you use Docker Compose, and you can aim that at the Podman endpoint. And it works pretty well. So let's do that. So I pulled down, I set up here a, let's see.
Maybe you can zoom in
yeah.
a little bit so that you need to,
I'm sorry. Oh, okay. Okay, I will just pull that down a little bit. How do I?
nearly, just need to resize it a little bit.
Yeah, but I can't get the corner. Oh, there we go. All right, how's that? And over a little bit. No, we don't need to launch Steam. All right. That is, can you see the M in Mark?
Yeah.
That'll do. All right. Okay, so you know the classic demo. You want to demo multi-tier application. What else but WordPress? No, I'm sorry. Yeah, it's still launching. All right, so you know it's a basic compose file, just MySQL and the WordPress front end. So if you have, I mentioned Podman dash compose. There's also Podman space compose, just to make it a little bit confusing. But that verb will use whichever compose provider you have. So if you have installed in your path Docker compose, it's going to choose that. So, which is all to say, I could run Docker compose, or now I can do Podman compose. What is it? So WordPress has started. You can see it's running there, and we have it set there. I think I had started to fill this out once already. Okay. So let's take that down. Is it, Thank you, completion. And what's an interesting feature is I can take whatever's running and export it to Kubernetes YAML. Actually, so I really didn't need to take that down, in fact. All right, so what I want to do here is Podman cube generate. And the first time I'm going to do this, we'll just do it to standard out, and you can see. So you can see it's actually taken the running compose situation and created a Kubernetes service, the pod, and the container specs, and everything is in there. And now I can just pipe that out to a file, which I've already done. In this case, by the way, there is, you know, not everything. It won't guarantee like every little bit is going to work. So in this case, I'll tell you the one thing I had to do is just change the name of the database and point it to the actual port. So let's take that down again. And we can, let's, for the sake of it, clear all the volumes. And now I can play that back. Publish all to publish the port. It was cached, so it fired up really quick. And we have a very similar output. The difference is, because we're running in a pod, we have the Podman pods container. That stays open to keep the network namespace alive in case all the containers die. Otherwise, it's the same scenario, and just for the sake of it, we will... Oh, it's flipping us straight to that. It must have saved the cookie or something. All right. So, okay, and there's one more tiny thing I want to show. So there are different types of quadlet files. The first one I showed you before is more like a regular service. And I didn't mention it, but when I say service, I really mean, you know, systemctl, status, start, stop works exactly like any other service that you would use. So it searches certain well-known directories for these quadlet files, which could be, you know, they could be user, they could be rootful, they could be various things. So in this case, I'm just doing it simple. So I put it into, let's see, containers. Oh, see, this is where I forget. I am on Mac. Okay, on Linux, much better now. All right, so if I go to, systemd, I've created a couple files here already. One is the same WordPress YAML that we saw before. Oops. No difference, except for one change I made in the database address. And then the other one is this .cube file. That's actually the quadlet file. And Oops, man, today my typing. What is controls? There we go. So this one's dead simple, right? It's just opening up the port and pointing to the YAML file to run. And now, as soon as that, as soon as that's running, again, I can just start and stop it. So let's do that right now. Let's see. So there's the service. Actually, I did want that. And there you go, right? It just looks like any other service, and that is that demo. All right. Do you want to go back to the deck, or?
I think I will switch directly to. But what's very cool? Thank you, Mark, for the demo. What is very cool with this demo is that you can see that you can just run very simple workloads onto any deployment unit in a Kubernetes fashion, so that it is making it very easy to go from containers to Kubernetes deployment very light, and then later on, if you need to scale them, you can go to a full-blown Kubernetes. So that gives you a gradual path to get there. So let's switch to Podman Desktop. It's probably not big enough, right? So I'm going to. What's going on? Okay. So, yeah, and then probably going to zoom in. It's probably a little bit dark, but here you can see the list of containers. And I'm going to close this one. So, yeah. And if it's dark, maybe I will just go into the preference and change it to light. Okay, that's better. Okay, cool. So this is my dashboard of Podman Desktop. That's where I can see the status of my system. I can manage the different engines that I am working with, but I can also see my environment running. If I have an update, it will call it out as well. I can see my different containers, my different images as well. So if I go here, for example, I can see the history of the image, I can inspect it, and I can also fetch the different layers of my image, and I can explore that as well. I have my volume, so it's really the UI to enable you to interact with everything you need to work with containers. Here I have a little container that is running. It's a Python frontend. So I can quickly get access to the logs. I can get a terminal. But what is interesting as well, which is using the Podman capabilities for generating a kube manifest, is that I have this kube tab, which gives me the manifest for deploying this container as a pod. I can also open my application, so it's connected to a Redis cache, and it's basic. It's just displaying the number of times I've been opening this page. And what is cool is that I can bring those two containers together as a single unit, because Redis is used as a cache, so I can bring this as a pod, so I can podify my application. I don't need to actually expose my Redis database, so I can create a pod here. And it will stop my containers, my 2 containers, and it will recreate them as a pod. Here you can see it. You can see the different logs of each of the different containers. And here, similarly, it's working as well, which is good. I can have the kube manifest as well, and I can use this for deploying onto a Kubernetes environment, which I'm getting into. So here we have a Kubernetes tab in Podman Desktop, which has been added recently. And you can see I don't have any cluster. So what I want to do is spinning up a kind cluster directly from here. So I'm going to just use the default settings for the sake of the demo. I can get access to the logs for the kind cluster creation. And once it will be created, I will see my kind cluster control plane here. You can see the logs. I can get into the terminal. I can do a kubectl, for example. I can directly interact with my kind cluster. But now, if I get back into my Kubernetes dashboard, I can see much more things. So I have an overview of my environment. So it's really giving me access to the nodes, to the pods, to the services, the config map, everything. So still in this motion of easing the transition from containers to pods and then to Kubernetes, what I'm going to do is taking my pod here, and then I'm just going to deploy it to my Kubernetes environment. So within Podman Desktop, we connect to your Kubernetes context. So you can reach a local Kubernetes environment, but if you are connected to a remote one, you will see exactly the same. So here I'm just using my kind cluster. Oops, where is my mouse? Okay. And it will replace the host port by a service, and it will use my kind cluster. So let's do it. So I don't need to mess up with copy paste or YAMLs here. It's just going to deploy. If I'm getting back here, yeah, it's waiting. So, but you can see that my pod is available. Is not available actually, but should get. Yeah. So it's probably. So let's do it. So I have it here. Take. And my pod. Just going to delete it. Take. Take. It should be error image pool. Pull back off.
Is it using the local registry on Podman?
I think in this one it should probably not.
You know what? It could be. I don't know if anybody else noticed, but I think this IP was rate limited by GitHub, among other things, earlier today. We were getting denied on stuff switched to the cell phone.
Yeah. So
Hey, there we go.
no, it's still not working. But what I wanted to show you is that you can also set up your port forwarding very easily. So you can click here to open. Of course, there is nothing running behind. And yeah, you can see your different port forwarding here, and so on. So I did the demo using Kubernetes, Kind, but there is also a Minikube extension which is available in the catalog of extension. Yeah, there is definitely. Oh, you're not having network anymore. So there is a. You see, it works local, but it does not work on prod. Anyway, I don't know. Anyway, I think it's so there's different extension for you to work with Kubernetes, so Kind and Minikube. And there's also a lot of other extensions. There is one for Quadlets that Mark was speaking about just before. And I will get back to the slide, which are...
Yeah, I'm not actually sure. Oh, there we go.
Okay. So...
Okay, let's see. Okay, I don't think I mentioned this. Z standard chunked compression. We'd like to see this become more the standard. Z standard by itself improves the speed of compression and especially decompression. But more importantly, it allows the chunked aspect will allow file level deltas. So no longer will you have to pull an entire container layer. This is going to be a dramatic decrease in network traffic. We're really looking forward to it. This is going to help as container images, in some ways, certain types get larger and larger. ComposeFS. I would love to do a whole talk on ComposeFS, but we don't really have time at this point. I think the tagline is an opportunistically sharing verified file system. It's not a file system, a true underlying file system itself. It combines OverlayFS, ArrowFS, and damn it, what is the third thing? But the point is, oh yeah, right, and FS Verity. So it's dense because it's a content addressable backing store. So every file is stored actually on the underlying file system as a hash of, the name of the file is the hash of the contents of the file. Immaterial of metadata. Could be the same, if the file is the same content, it could be on different directory, different date, doesn't matter, it's stored once. It's dense because, well actually, that's what I meant. It's fast because that file sharing also extends to the page cache. So if you're running the same base image and you have hundreds of containers running, it's going to load bash or glibc or whatever once. And then the second, 2+, it's going to be RAM speed. And it's verified because when you turn on the FS Verity option, which comes at a surprisingly small performance penalty, I think the original testing was around 3 to 5%, it's going to check the checksum on every single access. Believe it or not, this came originally out of some automobile effort that Red Hat was working on. You can't have a container fail in a car, right? this is a high safety situation. So even if a cosmic ray flips a bit, you need to throw that image out and use a new one. And that was, at least part of the motivation for this. But we can now, and I don't feel like I could before, use the capital I immutable here. Root cannot hack, cannot. Excessively difficult for somebody, even with root privileges, to change the system partition at this point. So we think it's going to be really exciting for both container hosts, but also this can be used with operating system file systems as well. So in the future, I think it's going to be great for appliances, Kubernetes nodes, all sorts of use cases. And yeah, okay. And just to mention on that, by the way, today containers are really only verified when they're pulled. By turning this on and having FS Verity running, you're making sure actually on every file access.
And for Podman Desktop, the roadmap is organized around 5 different themes. So installation and setup, tooling foundation, container management. And on this point, there is something which I want to drive a little bit of attention is we are doing a lot of effort to enable access to GPU for containers running on a Mac. So we've been working on a virtualization stack that allows to access the GPU directly from the Mac. It's called libkeren. So we've became a Sandbox CNCF project just a couple of weeks ago. For us, containers are really at the heart of cloud native technologies, and the developer should have the freedom of choice for tools that are truly open source. So we want to build an open and vendor neutral governance for the projects. If you want to get started with Podman Desktop, you will find all resources on the web. We have a website, we have our GitHub repositories that I invite all of you to start, obviously. And if you have adopted the technology, feel free to also add your name in the adopters file. It's also helpful for the projects to grow. With this, thank you.